Okay, this is chapter 3 for Pre-Cal 10. It's about factoring, which would be very useful next year for Pre-Cal 11, so you kind of want to pay a lot of attention to this chapter. 3.1, we go over a lot of your definitions and what you should remember from grade 9. The first of which is remembering what a prime number is. And remember that a prime number is basically any number that can be divided by only by 1 and itself. It only has two factors. So 2, 3, 5, 7, 11, 13, all prime numbers. I mentioned the word factor. Basically a factor is when you have a prime or composite number, two factors will make up that number. So when multiplied together, you get that number. So 3 times 4 is 12, 1 times 12 is 12, 2 times 6 is 12. All of these are considered factors of 12. And if I wanted to organize them in a way that's kind of easy to visualize, I can go numerically from least to greatest. So these, 1, 2, 3, 4, 6, and 12, are all the factors that make up 12. Kind of as a little aside here, a composite number is any number that is not prime. You're going to be asked to use a factor tree, which you should have done in grade 9, but just as a quick reminder, we'll break it down. What usually happens with a factor tree, if we start with something simple like 12, is you start dividing it down and breaking it down. You're trying to get to its prime factors. So, any of the factors I pick for 12, I could pick 1 and 12, but that's not going to get me any sort of advancement or headway. So I'm going to pick the numbers 3 and 4. Because I know 3 is prime and can't go any further. However, 4 can be broken down into 2 and 2. And the trick here with a factor tree is I can then go 2 times 2 times 3, and I should get 12. These are all the prime factors of 12. If we take this a step further, make it a much larger number, like 3,300, I can break this down the exact same way. So 3,300, I can first break it down into 33 times 100. Now neither of those is prime, so I have to keep going. I'm going to start with 33. 33 can be further broken down into 3 times 11, both of which are prime, so they can stop there. Now 100, there's two different ways we can break this down. We could break this down into 25 and 4, 10 and 10, 5 and 2, or sorry, 50 and 2. It doesn't matter which way you do it, you're all going to get the same prime factors at the very end. So I'm going to go, let's go 10 and 10. Because 10 can be broken down into 2 times 5, both of which are prime, and we'll do that twice. Now let's say I hadn't done that, and instead I had gone, let's go 4 and 25. Okay, again 3 and 11 are prime. 4 would be broken down into 2 and 2, both of which are prime, and 25 would be broken down into 5 and 5. So even though I broke these two steps differently, 2, 2, 5, 5, 2, 5, 2, 5, or 2, 2, 5, and 5. I get the same prime factors. And when writing down your total prime factors, again, it's kind of good to organize just so you can visualize it. This would be 2 times 2 times 3 times 5 times 5 times 11. Now something to note is your textbook really likes to turn these into exponents. So there's 2 times 2 is the same thing as 2 squared times 3 times 5 squared times 11. It doesn't really matter which way you write this down. These two things mean the same thing, but your textbook really likes this way for some reason. Don't panic, I usually write it this way. Again, back to grade 9, we're going to talk about the greatest common factor. So greatest common factor, you want to look at all the factors given for two numbers and see which of them they share in common. The fact that it's the greatest just means which is the largest one they share in common. So we have 138. We have all the factors of 1, 138, 2, and 69, 3, and 46, 6, and 23. If I reorganize that, I get 1, 2, 3, 6, 23, 46, 69, and 138. If I find out all the factors for 198, in this case I just skipped step 1 and organized it for you guys, with 1, 2, 3, 6, 9, 11, 18, 22, 33, 66, 99, and 198. If we want to see which of them they share, they do both share 1, 2, 3, and 6. And if we keep looking, in fact 6 is the largest common factor they share between the two. So if you ever have to find the greatest common factor, you write out all the factors, and I would stop once you've got them all down, and then you can basically see which of them they share. If you're looking for the lowest common factor, it's almost always going to be 1, so that's kind of a moot point. Your lowest common multiple, LCM. Basically, a multiple is if I have a multiple of, 5. Any multiple of 5, so I could have like 5 times 10 is 50. 50 is a multiple of 5. So we want to find the lowest common multiple, you're basically going to go up your times table. So 18 times 1 times 2 times 3 times 4, all the way up. If you do that for 18, 20, and 30, which I've done here for you guys to write out just all the multiples, so 20 times 1 is 20, 20 times 2 is 40, 20 times 3 is 60, etc. Same thing, same thing. We're looking for the lowest multiple that is the exact same. So this will take a little bit of eye work. We do know that both 20 and 30 have 60, but 18 does not. They also contain 120, again 18 does not. However, all three of them do contain 180. And if I look really closely, I believe that is the lowest common multiple. None of them share the exact same. And that's it. 3.1 is relatively short. It's most reminding you guys what you did in grade 9 and going from there. Your 2 questions. Nice and simple. For question 1, you have to find all the prime factors using a factor tree of 600. And for question 2, I want you to find the greatest common factor between 168 and 156. If you have any questions, again, I'll be online Tuesdays and Thursdays. Good luck.